Hello everyone, so today I will talk about the paper 48, Halal Cosmetic recommendation based on knowledge graph, the presentation learning. So we are from the Department of Artificial Intelligence, the Catholic University of Korea. So first, the problems and the need of building Halal Cosmetic recommendation systems. Muslim customers driven by religious requirements are increasingly seeking products that meet the specific HANA standards. And the problem here is that Korean cosmetics are often contains a wide range of ingredients and other complex compounds. And besides, cosmetic products often need ingredients under specific scientific and technical names that can be difficult for customers. And now in the world, there are about maybe 500 HANA certifying institutes operating around the world. And in here, we can see that no unified database exists to integrate and recommend the HANA certification data from these various entities. And the problem here is that it may lead to confusing among customers and business that as overlapping certifications may not align with the standards. And now there are several recent research studies they focusing on recommendation on products cosmetic product recommendations for Muslim customers. And there are several machine learning based methods like CNN on image or optical character recognition, and there are some shallow models. But the limitation of existing studies is that they only checking the ingredient list that is insufficient to decide whether the cosmetic are HANA or not. And in here, our idea is that we propose the use of cosmetic knowledge graphs and learn the relation between the cosmetic ingredients and also the ingredient properties. Here is an overview of our proposed models. So there are two phases in our models. The first phase is pre-training and fine-tuning the models. So it means that our model needs to be trained to learn the relations between products and ingredients, and to ensure that the model is well trained and capable of making accuracy prediction in real world. And the second phase is online inference. That means that given a cosmetic product, our model can recommend the top K similar cosmetic and HANA status. First, the first problem is that we construct the cosmetic knowledge graph, and in here we describe a cosmetic knowledge graph that represents the relations between cosmetic ingredients and their properties. And in here, a node entities may be cosmetic products, ingredients, or its properties. So in here, we summarize the node types and the relation types. In here, we construct 10 types of nodes as a 10 types of the entities. And for example, the cosmetic ingredients and categories and the ingredient properties like the toxicities and energies. And we also construct 4 types of relations that collecting between the entities in our knowledge graphs. So here is an example of our knowledge graph. There are 3 cosmetic products in the knowledge graphs. So, and then the next step is fusion layers. This is because ingredient properties have specific numerical attributes. So in here we Our solution is that we transform the entities in our knowledge graph into the latest space to generate unified representations by utilizing get functions like this. And then in our model, we use the relational graph attention networks. And in here, the proposed model learns the relationship between entities not based on the attentions. And that is, we calculate the attention coefficients for measuring the importance for each entity U for a given entity V. And moreover, we also want to effectively learn the good representations. And in here, we propose the use of initial Z0 connections and identity mapping to learn the entity representation at each layer, CNN layers. So for the pre-training phase, we now represent our pre-training task. That's what to learn the multi-relational structures between different types of the entities in our knowledge graph without using any label informations. This means that we are not use the HANA or HARAM information. And our solutions here is we preserve the coefficients across all the chipnets by using scoring functions. And here T refers to the set of the chip net nodes, head, relation, and tail. And for the fine-tuning phase, the model will do the prediction task. And in here, we only consider the two entity types, that's the product and status. And then we use binary cross entropy loss functions as for binary classification. And then the second phase is online inference. And once our model is pre-trained and fine-tuned, we then employ the pre-trained models to the recommendation task. And first, we filter a set of the cosmetic candidates within the same category as the given cosmetics, and then we obtain the representation vectors of these products to our fine-tuned models and the HANA probability of the given cosmetics. And last, we rank and obtain the top case similar cosmetic products based on Euclidean distance between the cosmetic candidates and the input cosmetics. For example, in here, the result showing the top 3 ranking similar products for each given cosmetics. So for the future research, we emphasize that the model can recommend more information cosmetic if we can have more data like product description and user feedback. And also, we also to recommend user-oriented recommendations, that we can give the recommendations for the products that user tend to like in the future, and the user, and as well as the user behaviors. And just thank you for listening.